We are in discussion for double differentiation, double differentiation of multivariable functions, multivariate functions. So if I have a function fxy, then what is dfxy by dx? What is d2 fxy by dx? So if I say that z equal to fxy, then what is dz by dx and what is d2z by dx? So if dz by dx is fxxy, then what is fxxxy? What is if dz by dy is fyxy, then what is fyyxy? And now if dz by dx is fxy, then and dz by dy is fyxy, then what is fxyxy and what is fyxxy? So there are four things that comes in the double differentiation for the multivariate function. One is fxxxy, fyyxy, fxyxy, and fyxxy. So fxyxy is nothing but d by dy of fxxy. So now let's consider that if this is x-axis and this is y-axis, x-axis, y-axis, and z-axis, vertical. This is xy plane. If this is xy plane, then fxy is, if I have one unit of change along x-axis, then how much z, the vertical direction, would change? How much variation is seen? That is fxxy. If one unit of change is along the y-axis, then how much vertical would change? That is fyxy. So these are fxxy and fyxy. So now fxxy here, all are x-axis, provided y is different. Fyxy here, fyxy here, fyxy here. Okay, all are fyxy dz by dy provided at different x. So suppose that z equal to x square y. This is what example we are taking. So z is equal to x square y. If that is true, then dz by dx is 2xy. d 2z by dx square is 2y. So when the first differentiation dz by dx is a function of x, okay, this proves that rate of change in x that is seen because of x is again a function of x. So it will vary at different x. So if dz by dx is 2xy, then at different x we have different rate in change. Anyway, at different y rate would change because it is function of y also. So now what is fxyxy? D by dy of fxxy. fx d by dy of fxxy or fxyxy. Okay, so if I talk, we have calculated fxx and fyy. So a rate of along x-axis there is one unit change. Then how much fxxy would change, and along y-axis if there is one unit change, then how much fyxy would change. So that is fxxy and fyxy. If I talk about in displacement and time variable, then it will come as velocity and acceleration. What is fxy xy and what is fyx xy? So suppose that we have kind of we now we have calculated the fxy. So with one unit change along x-axis, one unit change along x-axis brings how many unit of change along z-axis. So that is fxxy dz by dx. Suppose I have calculated that at a particular for a particular y. Okay, so this is partial derivative. Partial derivative along x-axis. So partial derivative along x-axis I have calculated for a particular y. Now let's go to another y. For one y, I have calculated dz by dx. Now I'll go to another y and I'll calculate dz by dx for y1 and y2. So if equation is x square y, then 2x y1, first derivative, 2x y2. Now I know the variation in z along x-axis dz by dx when y equal to y1. What is the variation in z along x-axis when y is y2? Okay, so if this distance y1 and y2 is delta y, if the distance if the distance between y1 and y2, so y2 minus y1 or y1 minus y2 is delta y, then how much variation is seen in dz by dx? Okay, so along x-axis when y is y1, what is dz by dx? Along x-axis when y is y2, what is dz by dx? Change in dz by dx by delta y is, okay, so is dfxy. Okay, dfxy, that is d of d by dy of fxy. Change in delta y means if there is a change in y, that is delta y, then how much there is change in fxxy. We calculated fxxxy. We calculated fyyxy. This is fxyxy. If I know fxyxy is d by dy of fxxy. So that is per unit change along y-axis. If I make, then how much fxxy would change? Dz by dx per unit change along x-axis bring how many unit of change in z? Dfxy by dy per unit change along y-axis would bring how much change in fxxy? That is fxyxy. What is fyxxy? Same thing. Now, if I know that fyxy at one x, fyxy at another x, then if it is x1 and this is x2, then d by dx of fyxy is fyxxy. So if at this location, what is dy by dz by dy? At this location, x1, x2, at this location, what is dz by dy? Now, if I know both value, then dz by dy at x1, dz by dy at x2, I have to subtract divided by delta x, whatever delta x we have taken. So, per unit change along x-axis bring how much change in dz by dy? This is d, this is fyx, xy. Okay, let's go back. Means I have now fxy, so it's variation in z when there is a unit change along x-axis. So I know that. So dz by dx, I know that. So dz by dx at y1 and dz by dx at y2, that we are calculating. And then we are subtracting and dividing by delta y. Let's think in another fashion. Now, at this point, when y equal to y1, when y equal to y1, I calculate delta, then I see y equal to y1 at particular x, y equal to y1 at particular x. Okay, what it means? in a different way, same thing I'm saying. So consider this way. So if y equal to y1 at particular x, what is dz by dy? Now y equal to y2 at particular x means another. What is dz by dy? So I have done delta y change and what is dz by dy at both location. Now at this location, this is x1, this is x2. At x1, what is dz by dy? At x1, what is dz by dy? At x2, what is dz by dy? At x2, what is dz by dy? So now we have dz by dy. Now if I, okay, so at x1, what is z? Let's better calculate this way. So there are 2 points, x1 and x2. At x1, what is z? Now y in y direction I am moving. At x1, what is z? Okay, I am coming back. So this I have to calculate. So now we have delta y. Here y is different. Here y is different. Now we have delta y and we have delta z because we are calculating for x1. So delta z by delta dz by dy at x1 we calculated. Now x2, what is dz by dy? Sorry, what is z? x2, what is z? x2, what is z? But there is a delta y gap. So there we have two z, one z, one z, dz by dy. So dz by dy at one location, dz by dy at another location. If I subtract this and divide by delta x, we get d d f y x x y. So can you see the similarity? One, how we calculated two. One is that I calculated uh, fxy dz by dx at one y1 and dz by dx at y2, and then what is gap in dz by dx, subtraction of dz by dx at 2 points divided by delta y. It is fxy. This is fxy xy. Now I take 2 points orthogonal. Here I calculate z x1. Here I calculate z x2. Now there is a gap of delta y. Then what is dz by dy? Again I calculate at x2 dz by z. At x2 I calculate the z. So there is a gap in z with delta y. So there are two z now. Okay. So delta z by delta y. If I know delta z by delta y in x2, delta z by delta y at x1, then if I subtract delta z by delta y at two locations divided by delta x, I get another way. It is same. Means the idea of talking this much is either I calculate dz by dx here and dz by dx here and divide and subtract both numerator of the dz by dx and denominator of delta y, or I take at x1 what is z, at x1 what is z, and subtract z by delta y, and x2 what is z, and subtract what is z here, and then then delta z by delta y. Okay, whatever we get, then change in delta z by delta y by delta x. Both are same. This proves that fx fxy equal to fyx xy. Okay, we are doing same thing, means one we are doing before and one we are doing after. It's like a into b equal to b into a. So fxy is same as fyx xy. Okay, so d by dy of fxy is same as d by dx of fyxy. So if I say d by dx, d by dx, sorry, I will go other way, d by dy of fxy. I have calculated fxy. So I have calculated fxy in one direction, and then For another y, I calculate the fxy in the same x direction. Now we have two fxy. If I subtract these two, divide by delta y how much in y direction I move, then I get d by dy of fxy. Now I want d by dx of fyxy. Fyxy means in two direction. Now I have to calculate change in z with respect to y. Now at x1 I have z value. At x1 I have z value, but there is gap of delta y. If that is true, then dz by dy at one point I calculate. Now at x2 I have z, and x2 I have z, but y is different. So d change in z with respect to y. So at one location I calculated fy xy. At another location I calculated fy xy. If I subtract both, then I'm trying to do d fy xy y dx. Both are same. Okay. One we are trying first and one we are trying. So multiplication, if we do a into b, that is b into a. So d d of d by dy of fxy and d by dx of fyxy. So d by dy of fxy and d by dx of fyxy are same. That is true. Then fxy is same as fyxy. Okay. So anyway, I you can see that I have tied one. Okay. So this is fxt. FXT in a sense that if you see, I am pulling it, and if I leave this, then there is a vibration. Okay, the string is coming up and down. So here it is fixed. Here it is fixed. Now if I pull it, then this is Z direction. This is Z. This is X direction. Okay, at any moment, then it is vibrating till it is coming down. Suppose that it keeps on vibrating. Okay, if I leave it, then it keeps on vibrating. So vibration, that Z is maximum at the center, where Z is going less and Z is zero here at this nail, and Z is zero here at this nail. So Z at any moment, Z at any moment is dependent upon distance from this location. If it is at center, then Z is maximum. Then if it is again going away, then Z is minimum. This is Z at any moment. Z at any x. Okay, if I keep the x constant, then still Z is moving. Z at any x, or if I keep the time constant at any moment, then Z is again different at different x. But if I say Z at particular x, then with the time, Z would be different. So the Z is a function of fxt. Z varies with the variation in x and variation in time. So not required that we do variation along x-axis and we do variation along y-axis. Okay, variation can be in x and t also. So that we'll see. I mean, it is little kind of difficult and complex. So we'll proceed on that, and then we'll proceed on kind of local linearity, improved version of local linearity. So that also we'll see.